Open on a world spinning on its axis, planets orbiting the sun, a basketball player executing a perfect spin move. This, my friends, is the magic of rotation. It's in the universe around us, in the sports we play, and yes, in the physics questions we solve for IIT JEE. Consider the concept of rotation, an object moving around an axis, much like our Earth rotates around its own axis. This fundamental yet fascinating concept forms the crux of many questions in the IIT JEE exam. Now, let's delve into the depths of a typical rotation problem often posed in the IIT JEE. Picture a uniform circular disc with a radius r and mass m. This disc rests on a frictionless horizontal surface. A horizontal force F pushes tangentially at the disc's edge. The question now is, what minimum force F will cause this disc to start rotating? To solve this, we must first understand that the force applied at the edge needs to overcome the initial static friction for the disc to start rotating. The maximum frictional force that opposes this motion is the product of the coefficient of static friction, often represented by m's, and the normal force denoted by n. The normal force in this case equals the weight of the disc. That's the mass m times the acceleration due to gravity, gg. We calculate the necessary torque tau to start the rotation using the formula tau equals sine r asterisk f. The condition for the disc to start rotating is that the applied torque must be greater than the opposing static frictional force. So we have Rn, which translates to Rmg. Substitute the given values and calculate. You'll find that the minimum force F needed to start the rotation is greater than msg divided by r. So there you have it. A deep dive into a typical rotation problem for the IIT JEE. Remember, the key to mastering rotation questions lies in understanding the underlying concepts and practicing regularly. The more you practice, the better you'll get at identifying the nuances of each question and applying the correct formulas. So keep at it and watch as the world of rotation unfolds before you.